Hey everybody, excited to see you here uh, digitally, I suppose, on April 2nd. We're looking at our next new stuff, graphing these rational functions. The good news is we're going to be utilizing a lot of the transformation stuff we've done in the past of shifting left and right, up and down, vertical stretches. So it's really about seeing the familiar shape of what a rational function is and then how we're going to move it with those asymptotes and how to look at it a little bit further. For homework, there'll be a standard homework that I'll collect, but also I'm excited about interactive Desmos practice. This Desmos activity is marble slides. You'll want to log in using your school Google BSD220 account to have it track your name and your progress. So I'll be able to record all that, but I'm excited to have you try that. And again, just a little bit more fun and different stuff, given that we've got the distance learning going on. So without further ado, let's go ahead and look at our next slide. Okay, so we're on page 435 of your book if you want to be following along. We're looking at the parent function, 1 over x, the simplest rational function we can have. Again, every rational function has to have an x in the denominator. So the simplest one we can make is 1 over x. We're going to learn about this one and then start moving it around, shifting it to find new ideas. We'll also put the basics on our word wall. So first of all, how do we look at 1 over x? How do we make this graph? So if I plug a half in, 1 over a half is 2. So half comma 2 is actually my first point. If I plug in 1, I get 1 over 1, which is 1. So 1 comma 1 is my first point. If I plug in 2, I get 1 half. So 2 comma half is my first point. And on the negative side, it's very similar. 1 divided by negative half would be negative 2. Negative 1 divided by negative 1 would be negative 1. And if I put a negative 2 in there, I get a negative 1 half. So on the other side, it's very symmetric. Negative 2 goes through negative 1 half, negative 1, negative 1, and negative half, negative 2. These are going to have vertical asymptotes and horizontal asymptotes as well. So I'll draw that in. A vertical asymptote at x equals 0 because I can't plug in 0. Dividing by 0 is not possible. And then a horizontal asymptote at y equals 0. And the function will approach these asymptotes and creating these nice, gentle curves. So as you can tell, there are no x-intercepts, no y-intercepts, but that'll all change once we start to shift this and stretch this. So that's kind of the follow-up here in question 2. Does it cross the y-axis or x-axis? No. And how could we show that using algebra? Well, let's review back from algebra 1. To find a y-intercept, so that's crossing the x-axis, you set x equaling to 0, so you have to plug in 0, which in my case would be 1 over 0, which does not exist, and so therefore there is none. So anytime you want to find the y-intercept, you're plugging 0 in for x, f of 0. If you're looking for the x-intercept on the other hand, where it crosses the x-axis, you have to think about, okay, where is the y value 0? Where's the output 0? So I put 0 in for f of x, so 0 equals 1 over x. I then multiply both sides by x to clear out the denominators, but that creates x times 0 equaling 1, and then that's 0 equals 1, which is just not true, so there is, again, no x-intercept in this case, but you can imagine if I shift this up or down, I'm going to have an x-intercept. So how do we then put this into our word wall? That's our next step. Okay, so here is our word wall, what I recommend putting down, just to have as a reference. Grab any sheet of paper or notebook you've got and start kind of taking notes throughout these next couple of weeks here at distance learning. Our parent function, the most basic function, is 1 over x. It's going to have a vertical asymptote. As x approaches this value, the output is going to approach infinity or negative infinity. These values, what values are they? They're the values that make 0 in the denominator. So in this case, 0 gives us 0 in the denominator, so that vertical asymptote is at x equals 0. But you could imagine it shifting left or right, so I could get x equals 2 or x equals negative 2 if my denominator changes. The horizontal asymptote, on the other hand, as x approaches the end values, positive infinity or negative infinity, so as x goes out to the end here, so I can kind of use this red thing here. As I go towards the end, the output's going to affect or approach a single value, in this case 0, and it will change depending on transformations. You can imagine if I move it up, the horizontal asymptote is going to move up. And then the intercepts. In this case, I don't have any because of the asymptotes, but that'll change. So how do I find my y-intercept? I'll find it by plugging in 0 for x. So I'm evaluating the function at 0. And for my x-intercept, I'm going to set the whole thing equal to 0 and then solve. In this case, 1 over x equals 0. We'll see that a little bit later as we go. And then after you have it graphed, what are the descriptions here? It is decreasing, decreasing. Its domain is everything except for 0, and its range in this case is everything but 0. But that'll change after you shift it up, down, left, right, and you'll have to interpret it appropriately. So let's dive back into seeing some of these shifts and transformations. Okay, so we're back here on page 436. We're going to start to see how these functions can change. We're going to look at vertical stretches here. So you notice in number 4, it asks us to look at 1 over x, 2 over x, and 5 over x. You can graph that on your own, the graphing calculator, to see how it changes. But I've done that for you here in the bottom left. So as you can see, 1 over x is in red. And then from there, we have the 2 over x a little bit further out and the 5 over x. So again, that vertical stretching really is apparent there. In fact, in the blue, I get 1 comma 2 because I just multiplied by 2. And in the green, I get 1 comma 5 because I just multiplied my output by 2 or 5, depending on what it is. So it's the same type of impact we've seen in the past. So how do the y values of g and h compare to what we've seen of the parent functions? So they are larger. Okay, and in fact, the x comma y original points are just going to x comma 2y for g and x comma 5y for the h. So I'm just multiplying by 2 or multiplying by 5, all of my outputs. But in reality, they all have the same vertical asymptote, horizontal asymptote, domain, range, x-intercepts, y-intercepts, etc. So could I quickly sketch these things out? If I've committed to memory what these look like, where those vertical asymptotes are, it should be pretty quick. So if I go ahead and graph 1 over x, I've got my vertical asymptote at 0, my horizontal asymptote at 0, goes through 1 comma 1, half 2, 2 half, all from our earlier work, negative 1, negative 1. I can draw those quick sketches in there. And if I go to graph 3 over x, I'm going to multiply all my outputs by 3. So half comma 2 is going to go through half comma 6. 1 comma 1 is going to go through 1 comma 3. 2 comma a half is going to go to 2 comma 3 halves, or 1.5. I also know it's going to go through 3 comma 1 if I just plug 3 into the 3 over x. And I can go ahead and graph that as a gentle sloping curve. And then on the other side, of course, negative half is going to go through negative 6. Negative 1 is going to go through negative 3 at this point. Negative 2, negative 1.5, negative 3, negative 1. And there's my 3 over x in blue. And again, if you want to try these on your own before I do, please make sure you're pressing pause. Let's take a look at a couple of different transformations on the next page. Okay, we're picking it up on page 437. In this case, these stretches are in the denominator. So really, this is 1 over b times 1 over x. And so really, it's a shrink instead of a stretch. All the things are getting smaller, so not much change. So if I look at 1 over 2x, or 1/2 times 1 over x, all of my original coordinates from my original graph, the x coordinates will stay the same, but the y coordinates will be multiplied by a half. So very simply, again, I'm going to commit to memory what my original parent function f of x is. It's got a vertical asymptote at 0, a horizontal asymptote at 0, goes through 1 comma 1. Notice the scale here has changed, and you can pause and try to graph these on your own. That's what I recommend, but I'll go ahead and continue. And at half, it's going to be at 2, and at 2, it's going to be at 1/2. I get this nice kind of gentle curve. And on the other side, negative 1, negative 1, negative 2, negative 1/2, negative 1/2, negative 2. And now I just got to multiply all my y coordinates by a half for h of x. So 2 times a half gives me 1, 1 times a half gives me a half, half times a half gets me a quarter. That's even more fun. And I get to draw in those nice sloping curves. So notice it's on the inside here. Negative 1, negative half, negative quarter. It's got the same shape, but it's just been shrunk or compressed if you imagine grabbing vertically and pushing down on your graph. So one other function we've seen in the past, or one other transformation we've seen in the past, is this, putting a negative in front. So let's predict. Basically, it would be a reflection. A reflection across the x-axis. So that would move this top part down to the bottom, and this bottom part up to the top. In reality, it's taking my original points and taking them to their negative y counterpoints. The output gets multiplied by a negative. Okay. Our next part asks us to describe how we would change the coordinates for negative 2 over x. So again, x comma y is going to go to x comma negative 2y. I'm going to multiply by negative 2 for all of my coordinates, and I'm going to pick that up on the next page because it's actually what it asked me to do in number 13 is to actually graph that point. Okay, to save time, 13 asked me to graph negative 2 over x using this x comma negative 2y transformation. So I recopied the original table from the beginning of the lesson. And so real quickly, I'm just going to find all of my new points here and plot those. So half 2 becomes half comma negative 4, half negative 4, and I'll go ahead and plot that. You can try and do this on your own. 1 comma negative 2, 2 comma negative 1. And my vertical asymptote and horizontal asymptotes are going to be that same x equals 0 and y equals 0 spots. So I knew it was that nice gentle curve. It's now just below the x-axis instead of above because of that negative piece. Negative half is going to go to positive 4 this time. And negative 1 is going to go to positive 2. And negative 2 is going to go to positive 1. I get that nice swooping gentle curve. So that takes care of 13. So it asks about the horizontal and vertical asymptotes on all these different types of reflections, stretches, and shrinks. In all of them, we saw that the vertical asymptote and horizontal asymptote were always the same. X equals 0 and y equals 0. So they're always the same. We can't move the vertical or horizontal asymptotes with these stretches or shrinks. We can only move them with the shifts left and right. And obviously that's where we're going to go next in terms of what we're thinking at. So again, as we look at this next section on 15 through A through D, it's going to have us do left, right, up, down, and all the good stuff that is involved with that. So this first one they've already done for us. X plus 2, notice it's in the denominator, so it's affecting the x, not the output, it's affecting the input. So this is shifted 2 units to the left. So again, we notice the vertical asymptote is what moved to the left, the horizontal asymptote stays in the same spot, and they're able to easily graph 1 comma 1 from this new kind of center point, and negative 1 from that new center point, and draw in those quick curves. They could have also just plugged in numbers. If I plug in 0, I get 1/2. If I plug in negative 1, I get 1 to get some key points. So again, best way to do this, draw the asymptotes and then get some key points. So I'm looking at B. This has been shifted to the right 2 because it's x minus 2. So my vertical asymptote is at x equals 2. My horizontal asymptote is at y equals 0. And again, if I plug in 3, I'm going to get 1, because 1 over 3 minus 2 is 1 over 1. And if I plug in 1, I get negative 1. So I get this, and I get this, and I'm able to draw a quick sketch of that. It looks very similar to the original, just shifted to the right 2. This one down here, 1 over x plus 2 now, notice it's on the main level, so that is going to be an up 2. It's affecting the output or the y value. So in this case, my vertical asymptote will not move, x equals 0, but my horizontal asymptote would be shifted up 2 to be at y equals 2. If I plug in 1, I get 1 plus 2, so that's 1 comma 3, and I can now go ahead and draw in that nice smooth curve. If I plug in negative 1, I get negative 1 plus 2. So I get positive 1. So I'm able to get this particular graph. And if I move down 2, it's very similar, just obviously moving down 2. You can pause and try that yourself, and then come back to see the answer. So horizontal asymptote, y equals 2. Vertical asymptote stays the same, x equals 0. If I plug in 1, I get 1 minus 2, so I get negative 1. I know it's going to approach those asymptotes. And if I plug in negative 1, I get negative 3 out of that. Okay, we're closing in on the end here, putting everything together. On 16, we're going to take a look and just describe each of these. So go ahead and pause and try that yourself, and then I'll reveal for you which way they're shifting. And then in number 17, same thing. Once you know which way they shift, are they going to cross the x-axis? Just have that picture in your head of whether they cross the x-axis, y-axis, or both. And so as I look at this with A, pause, I'll reveal the answers now. This has been shifted to the left 1. On B, this has been shifted down 3. And on C, we're going to the right 5 and up 3. So 2 different shifts. And then, of course, if I think about how that's going to move things, if I'm moving it left 1, that means I'm going to cross the y-axis for letter A. For B, I'm moving it down, so I'm definitely going to cross the x-axis. And for C, since I'm moving both directions, it's going to cross both directions. And we'll see that all put together in the final example that will work together. First, let's look at them. Working through an example in the book, it gives us a more complicated 2 over x minus 3 plus 1 as a transformation. So I know it's shifting to the right 3, up 1, and there's a stretch of 2 here. And the best way to do this is to graph your asymptotes first. So right 3 means I got a vertical asymptote at x equals 3, and a horizontal asymptote at y equals 1. And then I think the best way to do this is to find your x-intercept, y-intercept, and maybe a couple other points just by plugging in. So again, to review from Algebra 1, the y-intercept, you plug 0 in for x. If I plug 0 into the original, negative 2/3 plus 1 gives me 1/3. 0, 1/3 is my y-intercept over here. And to find my x-intercept, I set the whole thing equal to 0. So 2 over x minus 3 plus 1 equals 0. Bring the 1 over, multiply by x minus 3. That gives you 2 equals negative x plus 3. Subtract the 3 over. Negative 1 equals negative x, and x equals 1 as my x-intercept. To graph this f, I plug in 4. When I do that, I get 2 over 1, which is 2, plus 1 is 3, so 2 over 1, and I can draw those nice swooping curves in. So let's work this together. There are 3 examples below where we'll work through all of them together. I'll show you the answers here in a moment. But we're going to work through letter C all together, and then the other 2 I'll let you try on your own. You're going to identify x-intercepts, y-intercepts, and asymptotes and sketch the graph. So go ahead and pause. I'll get set up for letter C. You can get set up if you want to, and then I'll talk you through it. Okay, so how do you attack these? I've set up my axis, and the best is to identify what are the transformations. So I'm dealing with a shift up of 3, a stretch by 4, and then a shift right of 2. And so as I think about this, the up 3 is going to change my horizontal asymptote to be y equals 3 from y equals 0. So I can draw that in. And the right 2 is going to shift my vertical asymptote to be at x equals 2. Now I need some points to plot. So a couple different ways of doing this. I'm going to dip my x and y-intercept first. So I'm going to start with my y-intercept because that's just plugging in 0. So that's 3 plus 4 over 0 minus 2. And so that becomes 3 plus 4 over negative 2. So that's 3 minus 2. So that's equal to 1. So 0, 1 is my y-intercept. So there's a great point. And then for my x-intercept, 0 equals the whole thing. 3 plus 4 over x minus 2. I got to bring the 3 over. Negative 3 equals 4 over x minus 2. I'm going to multiply both sides by x minus 2. So negative 3 times x minus 2 equals 4. The distribution, of course, is really important here. Negative 3x plus 6 equals 4. And then solving that gives me negative 3x equals -2, x equals a positive 2/3, which makes sense. This is just short of 1 here, and so I'm able to get in my first swooping curve. How do I plot in this upper right-hand corner? Really simply, I'm going to plug in x equals 3. What is f of 3? F of 3 is 3 plus 4 over 3 minus 2. So 3 plus 4, so that's 7. So the point 3 comma 7, 5, 6, 7 is on my graph. I'm going to extend my asymptotes a little bit here. And again, it's this nice swooping curve. You could plug in a couple other points to get a little bit better picture, but really the things I'm looking for, most importantly, are your asymptotes correct, vertical and horizontal? Are the x and y intercepts correct, if they exist? And then again, 1 or 2 other points just to help you draw those smooth curves in by hand. So go ahead and take a look at A and B, and I'll show you those answers on the next screen, but I want you to try them yourself. So here are the answers to all three, A, B, and C, even though we talked through C together. Take a look at those. Make sure that you understand where those answers come from. You can hit pause to really dive deeper into it. But on your homework, there will be a couple where you'll just have to graph by hand. And then a lot of the other stuff with the Desmos activities will be about just adjusting, is it moving too far left, too far right, and trying to capture all the stars on the marble slides. So you should have fun with that. Again, I'll be hosting office hours. Looks for where that's posted on Zoom as well. I'll be hosting those in case you have any questions. The rational function here, we can finish up with these last couple of questions just conceptually. If I'm looking at a rational function that's been vertically shrunk by a factor of 3 and then translated down 5, where are the asymptotes? What we've learned from this unit is that the vertical and horizontal stretches don't move the asymptotes, but only the translations do. So I'm looking at just this down 5 units. So that's going to move my horizontal asymptote to y equals -5, but my vertical asymptote is going to stay at original x equals 0. And then finally on 19, can you just look at this and describe those transformations? Yes, I can. And that's going to be, of course, left 1, down 3, and a stretch by 4. And again, how do I find the x and y intercepts? If I'm finding my y-intercept, that's f of 0. So I just plug in 0, 4 over 0 plus 1 minus 3. So that's 4 minus 3 or 1. So 0, 1 is my y-intercept. And then my x-intercept, a little bit harder. But again, 0 equals 4 over x plus 1 minus 3. I can bring the 3 over, 4 over x plus 1. I'm going to multiply both sides by x plus 1. That clears the fraction on the right, and I get 3x plus 3 equals 4. 3x equals 1, x equals 1/3. So 1/3 comma 0 is my x-intercept. So being able to solve for those is going to be really critical. Email me, message me through Schoology, or drop in during the open office hours if you've got any questions. There's a homework worksheet for you to work through, as well as that interactive Desmos activity. I think even starting with the interactive Desmos activity will let things click a little bit better. And like I said, excited to get your feedback on this. But this is the basic 1 over x, and then translating it left and right, up and down. We'll look at a little bit more exotic graphs starting next week on Monday. Take care.